All right, guys, we're talking about special number sets today. Let's start with the one we learn first when we are growing up. N, the set of natural numbers. You will notice that in maths we use kind of a calligraphical way. So you will see this written sort of using two bars here on the left, and then written this way, just using straight lines for the rest of it. Or you can see this sort of thing. You've got an N, then you've got like a double line here in the middle, and then you've got another vertical line here. It's like a bit of calligraphical. But in any case, these are the sets. This is a set of natural numbers. So 0, 1, 2, 3, 4, 5, 6, 7, all the way up to infinity. Just carries on forever. There is a bit of dispute whether 0 should be included here or not within the academic community, but for the purposes of the IB, 0 is included. Then we move on to the set of all integers. I think I've mentioned this stuff previously, but we haven't had a proper lesson on it. The next one is basically the set of all integers, Z. And once again, we've got a bit of a calligraphical way of writing it here. We'll put like a double line in the middle, for example. Okay, so we've got this is including all the negatives as well. So we've got 0, 1, 2, 3, 4, 5, 6, etc. But this one includes -1, -3, as well as the natural numbers. Now, if you put a little cross next to it, it means it's just the positive integers. And by the way, if you were to put a minus next to it, then it would include the negative integers. So it would be something like -4, -3, -2, -1, all of these numbers. Right, and then we've got the rational numbers, which we use a letter Q for. You might see this written like this. This is how I tend to do it. I'll put a little line there. I know it doesn't look great. This is a bit of a bold kind of way of writing it down. By the way, this Q comes from quotient. Quotient, which means ratio, fraction, that sort of thing. And this Q means that we have all the whole numbers we had before, but also any fractions or decimals. So yeah, this Q basically includes decimals like 0.1, 0.2, you know, so for example, let's say 0.1, 0.2, 3.14, 5.17, -2.23, includes fractions, like you could have 2/3, you could have -5/7, etc. But you also have one special group in here, which you might be a little bit surprised about. This would be recurring decimals. So although never-ending decimals are not included in rational numbers, so if you have something like pi, which is an irrational number, it's not included in these numbers, but recurring decimals like 0.3 recurring, this would be included because you can actually write it down as 1/3. And then, for example, 0.6 recurring is also included because it's 2/3. So these recurring decimals, which are never-ending decimals, but have a way of writing them down, we have a way of writing them down as a fraction, they are included in the set of rational numbers. So you might get a question like, oh, is 0.3 bar, 0.3 recurring, rational? You will say, yes, it is, because you can write it down as 1/3. Is the root of 16 rational? Yes, because in fact, they're trying to trick you here. The root of 16 is actually equal to 4, which is 4/1. So yes, it is rational. But there are numbers which are called irrational numbers. And the reason they're called irrational is because you can't write them down as a fraction. Not because they're crazy numbers, but because you can't write them down as something over something else using whole numbers. For example, the root of 3. This one, if you put it into the calculator, you will see that it gives you a decimal and it never ends. It just carries on forever. Like the root of 3, let's just work it out very quickly. So apparently, according to my calculator, it's 1.732050808. It just carries on forever, never ends. And you can't write it down as a fraction using whole numbers. So it's irrational. Pi is also the same. Pi is 3.141592653589, etc. It just carries on forever, okay? It just never ends. And you can't write it down as a fraction. So it's irrational. Okay? And then the final set we're going to look at is the set of real numbers. Now, the real numbers are rational numbers together with irrational numbers. So it's like everything you can ever imagine of. So real numbers also include roots, negative roots, pi, combinations of pi and roots and all of these numbers, anything you can think of. So here, that would be the letter we use for this is this calligraphical R. Oh, by the way, here the notation we're using in the IB for the irrational numbers is Q with a little dash there, which indicates it kind of means the complement of Q. It's what is not in Q. So complement of Q. So what's outside of the rational numbers. So let me just give you a visual representation of all of this stuff. Basically, if I were to draw a little Venn diagram here at the bottom right corner, in the center, we have the numbers we learn in primary school, then natural numbers. And then after that, we learn about negative numbers, possibly in year 7 or something like that, when we start secondary school. And then outside that, you've got the rational numbers. Rational numbers are all the fractions, etc. Outside the rational numbers, you've got the irrational numbers, which in fact are a lot more than the rational numbers. It's just that our human brain can only fit the rational numbers. It doesn't have enough space for these ones. They're very weird for us. And then this entire Venn diagram altogether is the set of real numbers. So it's all the numbers that we know at this stage. Eventually, we'll talk about complex numbers, which are outside this, but let's just save that for later because it's I don't want to confuse you. Right, basically that is the idea. So today what are we doing? We're just classifying numbers really using this classification we looked at. So we will be talking about, oh, is this number a natural number? Is it a whole number, an integer? By the way, let me just clarify something. When we said integers here, we have another name for this. We say whole numbers. So in everyday life, you might say instead of integer, you might say whole numbers more often than integer. So keep that in mind. I'm going to upload this with the annotations. So please have a go at this, remembering the set notation we've seen. So this little letter that looks like a Greek epsilon, it means is an element of. So it's an element of that particular set. If you have a line going through it, it means it is not an element of. So keep these two in mind. When you've got the square root of a negative number, as was mentioned down here at the bottom, this one is actually even not a real number. It's the one that gives you a math error. It's something that we haven't studied yet. It's something we will see later on in the IB course. Basically, when you've got a negative number under a square root, this is not a real number. So this is actually something that you, at this stage, will just remain confused about. Feel free to remain confused about these things. I'm not going to tell you what they are until we actually talk about them later in the spec. Just give me a second to stop the recording, and then I'm going to get people to ask questions, and I'll be happy to answer them.